Hello everyone. So today we are going to study about our digital image processing's introductions subchapter number 5, and we are going to discuss mainly about histogram processing, its image histogram, histogram equalization, and also we'll be studying the histogram matching, that is also called as histogram specifications. And in that we are also going to see the practical implementations, numericals, so all those things we'll be seeing in today's class. So to understand histogram based systems, what is the application of that one? But I mean, where we are going to implement that? So our main topic is actually image enhancement, where histogram equalization and histogram matching is going to be used. So what is image enhancement basically? So image enhancement is actually the capability of image processing to enhance the quality of the image in two terms. Basically, it will be visually more appealing to the human eyes, as well as it will also be very accurate for machine based operations, like for example for robotics, for computer vision. So all those applications will be better when the image is enhanced using digital image processing. So officially you can say the definition is the process of improving the visual appearance of an image or making it more suitable for analysis is actually your image enhancement. So what is the main purpose? The main purposes are, first one, to highlight the important features. Okay. Second one is to suppress the irrelevant details. Third, to improve the interpretability for human viewers and machines. They will be able to understand it better. Then image enhancement is basically divided into two parts, but there is a third extended category as well. So first, you know that we have been studying for a very long time about spatial and intensity based transformations. So spatial basically represents the space, the position, and intensity basically represents the level of intensities we have, the brightness levels we have in the complete image. That is your intensity level. And the third one is the combination. So the first one is about spatial domain method, where we just directly manipulate the pixels. The second one is your frequency domain based methods, in that we basically transform the intensity values. And the third one is the combination of all of these two. Okay. So moving forward, so the first technique is about image. We have histogram equalization. So what is histogram equalization? So to understand histogram equalization, we should first know what is histogram. So let's move. So when you see here, you can see this complete image, as I have told in many of my previous talks, that every image can be converted in the form of pixel. So I mean in the form of intensity and the pixel as well. Okay. So you can see every image can be converted in the form of a matrix, in that each intensity level will be your pixel value, or you can say the matrix value, the element of that. So that only I'm showing here. So every image mathematically to our system, it looks like the number. So for example, if we are taking this image in this format, so since we have to do manual calculation, I have taken a 3 by 3 matrix, but it can be your 1000 by 1000 also. Okay. And in any different orders. So what is histogram? It's basically representing the different pixels in how many times it came in the complete image. So for example, you can see here 52 comes how many times? Only one time, so we'll be representing it one time. Then 55 comes one time, so we'll be representing one time. Then 59 comes how many times? One time, so we'll be representing one time. Okay, but 61, you can see it came three times. 1, 2 and 3, so we'll be representing it three times, right? Then remaining 62, 76 and 79 came one time, so we'll be representing one time. So totally how many pixels are there? Totally 1, 2, 3, 4, 5, 6, 7, 8 and 9. So totally 9 pixels are represented in the order, in the frequency of how many times it appeared in the image. That is your histogram. Okay, so you can see that how you're going to convert your complete image intensities in the form of histogram. Moving forward, we have histogram equalization. Now you know what is histogram. Okay, so histogram equalization is nothing but adjusting these values. You know that we are moving toward 0, we are moving toward black, and we are moving toward 255 for an 8-bit image. Of course I'm talking. In that case, we are moving toward white. Okay, So now what is happening? You think if the equalization is not correct, what will happen? Some places will be too dark, some places will be too bright. So that should be adjusted correctly, and that process is done using histogram equalization. So histogram equalization's actual definition is it's a contrast enhancement technique that redistributes pixel intensities so that the output image uses the full available gray level range more uniformly, so that our eyes will be able to catch it correctly. And same the machines, that computer vision systems, robotic system, or drone based technology will be able to identify those things clearly, those pixels value clearly, if they are uniformly distributed, correctly distributed basically. So what is the main implementation and application based benefits? So that is, it improves the visibility in low contrast images, where you can see that your eyes are not able to identify the minute details. There it will be very useful. Second, it enhances the details in darker or bright regions, too bright and too low, the same thing they are telling here. And automatic contrast enhancement, it's automatic process. You are not going to give any manual intervention. Okay, it will automatically target. If you give the input image, and you will give the formula of histogram equalization, it will automatically adjust the pixels that is more visible to your eyes and two different machines. So that is the overall process of histogram equalization. Now we'll be seeing what effect it can bring to the image. So imagine this is the image, and you can see on the down of that the histogram is actually mentioned for that one. This same image taken from a hardware that is a low quality. You can say the basic mobile phone. But after histogram equalization, the same image can be converted into this image. And it's equal to a very good quality camera taking photograph in correct lighting condition, and that all will be happening on the machine level, on the programming level itself, and without purchasing very high quality camera, or without investing lot of amount in that one. So that is the main advantage of histogram equalization. Now you can see that how we are going to perform. You know that histogram equalization is actually spatial domain operation. So in that, what we'll be doing, uh, we'll be having the question like this. So our question is, we have a 3 by 3 image. It means number of rows and columns are in that image are actually 3 and 3, and it's an 8-bit image that is already declared in the question itself. You remember why this 8-bit is important. Okay, so coming to the solution, first what we have to do, we have to create the table. Okay, so what is the table? We have to create the table in the sense that RK represents your gray levels. Okay, so gray levels means what is the intensity value, that is actually your gray level, and that is represented by RK. The number of pixels, that is NK. How many times those pixel values, those intensity values came in the complete image, that is your frequency value, that is represented by NK. So you can see here 52 came one time, 55 came one time, 59 came one time, 61 came three times, 62 one time, 76 one, and 79 also came for one time. That one table you have to create. Using this table, you have to create the histogram. So like this, you have to create the table first from this matrix, or if the table is already given, no problem, you can directly use that one. But this histogram is must. You have to create this histogram using your paper and pen or whatever technique you use. Next, the step one was to create the histogram, right, and the table. Second step is to calculate the PDF. PDF is nothing but probability distribution function. Probability distribution function is a very simple calculation. I'll be showing you that one. So we have these different gray levels that we already know. We have these frequency values. Then we have to calculate the probability. So probability is nothing but that pixel impact over the complete pixel. Okay, so basically you can say nk divided by n. So nk is what? Nk is the total sum of your pixel. Like, I mean, how many pixels are there? 1, 2, 3, 4, 5, 6, 7, 8 and 9. So totally 9 pixels are there, divided by n. So what is n here? N is the number of pixel, that is 9, and that will be divided by this nk value. So nk is what? 1, 2, 1, 1, 1. So 1 divided by n means 1 divided by 9 is 0.111. Okay, then here 1 divided by again 9, that is 0.111. Again 1 divided by 9, that is 0.111. But 3 divided by n is actually your 0.333. Okay, so like that we have to calculate. That is your PDF. Coming to that CDF, CDF is also very easy actually. In this CDF, what we are going to do, so in this we will be calculating, CDF is nothing but the summation of previous PDF values. Okay, so first CDF and PDF will be same, because you know that the first value will be directly copied here, and in the case of second value, what we will be doing, we will be adding these two values you can add, or these two values you can add. Okay, so you can say that I'm adding this one, and here with this it gives me 0.222. Okay, then we have the third value we want to identify, so for that we have to add this one to here, and we'll be getting 0.333. Then again for the next step, 0.666, we have 0.333 plus 0.333, and for 0.777 we have 0.666 plus 0.111. It means this will be the sum of 0.888 plus 0.111. So basically you can calculate this CDF. That is very easy to calculate. Now what we have to do, we have to find the round off value. So round off value is also actually it will give you the equalized pixel value. So this formula will be applied. So formula is very simple. What you have to do, round off CDF multiplied by L minus 1. Okay, so L minus 1 is what? What is L value here? L is actually nothing but number of gray levels. So in our question, we already know L is the what bit of image you are basically using. So our image is an 8-bit image, that I have told in the question itself. That our question says that is the 8-bit image. So we will straight away put here 8. So this will become 8 minus 1, means it will become 7 here, multiplied by CDF values. So CDF values will be your 0.111. So 0.111 multiplied by, I mean for the first value 0.111 multiplied by 7, it will give you some value, and that will be your like 28.305, and that you have to round off, that is 28. Okay, so this value, it will be like 57 point something, and that's giving its 57 value. Then this will be 85 point something, so because of that it's coming 85, and likewise these all values will be coming. Okay, so new gray levels you have to calculate. Okay, so process is simple. The same thing sometimes they are doing differently, means same thing, but calculation wise they will be doing differently. What they will be doing now, first they will be calculating this value of L minus 1. So it's always 7. 7 is constant for everyone. Then this 7 will multiply with CDF. Then 7 multiplied with this will give it 0.777. Okay, then one table will be formed here. 7 multiplied by CDF. Then one table will be there. Okay, then round off value, another table will be there. In the round off value, it will be like round off value will be 28.305. Then the answer will be 28. So our ultimate requirement is this table only. So that we are doing here in a single step. Okay, so this 28 will come here, and now our original value will be converted into this value. So how it's coming? We have got it from here itself. 52 became 28, 55 became 57, and 59 became 85, and 61 became 170. So like that it goes. So this is your final result. So you have to display it like this, and you have to create the histogram here also, like we created initially. Okay, so this was all about histogram equalization. So if you know histogram equalization, doing histogram specification or histogram matching is much easier. So histogram matching and histogram equalizations are very important technique in digital image processing, because they are little confusing. So because of that only, actually they are in much in demand, because practically also you can implement it in real time. Okay, moving forward. So histogram matching means what? So first we had histogram equalization. We have an image. In that image, some you can say that abnormalities are there, because the pixels are not correctly distributed. Now what we are going to do in histogram matching, the distribution is already there, it's already correct, but we are not able to correct it further, because histogram equalization sometimes enhances the noise also. If noise is already there, that also will be enhanced. Okay, so in that case we need something, some reference value. So it's like, suppose in a class, suppose 20 students are there and somebody did a very good assignment. So what we'll do, we'll tell to other student that you just follow his format and make the assignment like this. So now what result will come, that will be better compared to the previous one when individually everybody gave. Some reference point you have, I have to make like this. So that is your histogram matching technique. Okay, so what we are going to do with this, what benefit it can do, that will be showing you right now. So histogram matching transforms an image so that its histogram matches a given desired target histogram. So in this case, you need a target histogram also, and your image should be looking like histogram. It should be using the features like your target histogram. Okay, so it basically used to obtain a specific visual appearance. It brighter, darker, or whatever it is. So that will be automatically adjusted based on that image. Okay, to match the tone of one image with another image. Similar, useful in medical imaging, remote sensing, and image normalization. In different techniques used, it's very useful. You'll be seeing that right now, how useful it is. You can see in this case, this is a problematic image, and we have an image which is very clear. So what we can do, we can use the reference histogram of this image and apply to the problematic image. Then this problematic image will become like this image, very clear, like this, because the capability of this image is transferred to this one using histogram matching technique. Now this was the visual thing. Now how we are going to do that one? So we have this histogram, we have this histogram, we have to achieve this histogram, that we are going to identify right now. So questions will be like this. Given below are two histograms, 1 and 2. Modify the histogram 1 such that it matches the histogram 2 using the histogram matching technique. Okay, so let's have the questions. So this is your input image and this is your target image. Okay, so we have also given you this one. So one small rule you should know, that in histogram equalization, number of pixels will be, I mean, if you add this all these pixel values, the values will be same. Okay, so if you add 70 plus 95 plus 85 plus 60 plus 35, this image and this image values will be same. Okay, why we are doing like this now? Because this is the rule, because otherwise a very big image, very different image cannot be mapped to one image. Okay, so because of that, the image should be similar. Okay, taken from the single it should be very similar, so that only it can be applied. Okay, so let's have a look on the histogram of these images. So histogram of input image and histogram of output image I have already drawn. You can see here 0 came 75 times. So 0 came 75 times. Okay, 1 came 95 times. So 1 came 95 times, and 2 came 85 times. So 2 came 85 times. So like this only I have drawn. Okay, here also you can see that 2 came 35 times. So 2 came 35 times. Okay, and 104 3 came 104 times. So 4 came like this. 4 came 156 times, like that. So exactly like this you have to draw the histogram. Okay, now here I have calculated all the values that you will be calculating. So it's very simple. You know that calculating this one it's very simple, but at the same time it's little confusing. So calculate it with great patience, then only you'll be getting the correct answer. Okay, so first of all, we will be having this, you already know from where it came, because this is the sequence, and this is your intensity values. And here what we are going to do here is, you can see that if you add all of these, it will become 390. So your first value comes from 70 divided by 390. Okay, you remember nk by n, that value. Okay, where n is the number of these values. Okay, so 70 divided by 390 will give you this value. Okay, 95 divided by 390 will give you this value, and 85 divided by 390 will give you this value. Okay, likewise you can calculate all these values. Now moving forward, what we'll be doing here, this is called PDF, because we are dividing it with the total value. Okay, so 70 divided by 390 is actually giving you all this value. Like that you can calculate this one. CDF, you already know that first value of PDF and CDF are same, because this value we are transferring here. Okay, and this value plus this value is this one. then this value plus this value is this one, and this value plus this value is this one, and likewise it goes. Okay, so you can see that ultimately it's coming 1. Then here sk into 7, okay, sk into 7 is means this value multiplied by 7 is this one, this value multiplied by 7 is this one, this value multiplied by 7 is this one, this value multiplied by 7 is this only, and likewise you are getting 7 here. Okay, and these are the rounded values. So 1.2 is actually 1, 2.9 is 3, 4.4 is 4, and 5.5 is 6, 6.1 is 6, 6.6 is 7. Likewise, I have calculated the rounded values also. So in the previous histogram equalization, we have done this in a single step. Okay, we had the formula, no, round off your sk multiplied by l minus 1. So since this is an 8-bit image, why I am telling 8-bit image? Actually you can see that not 8-bit image. Actually, this is a 3-bit image. So 3-bit image, why I am telling, because the values you can see. 3-bit image means what? 2 to the power 3. 2 to the power 3 means 8. So you can see these values are under 8. Okay. So since these values are under 8, so this is a 3-bit image. Okay. So since this is a 3-bit image, we have actually the total maximum value of that is going to be 8. So because of that only 8 minus 1 is 7, and that is multiplied by your this value. Okay. So you are getting this one. Till here I hope it's clear. It's exactly same like we calculated previously. If you calculate like that also, it will come the same value only. Now moving forward, why how this value is coming? Okay, so you should see the rounded value of this is 1. Okay, so rounded value of this is 1, it means this 70. Okay, that will be coming here. The rounded value of this is 3, so this 95 will be coming here. The rounded value of this 4 is the rounded value of this is 4, so this straight away this 85 will be coming. Okay, but here there is a problem. Rounded value of this one is 6, and rounded value of this also is 6. So these two values will be added. Okay, so that is 60 plus 35, that is 95. So you should write only one 95. Okay, another one is will be, you can keep it blank or as you like. So now moving forward, so since the value of this is also 7, this is also 7, this is also 7, so for 7 the common value will be 25 plus 15 plus 5. Okay, the answer will be 45. Okay, clear? Since this is having only one value 70, only one value, so 95, only one value, so 4. Here the two values of 6, so we are adding 60 plus 35, that is 95. Here we have 3 values as 7, so we'll be copying all the NK values of this one. So 25 plus 15 plus 5, that is your 45. Okay, that is the final answer. So ultimately we have these values. These are new NK values. Okay, so now remember two things. First, this RK, how many values of the pixels are present, that one. And then the rounded values what you got. These are two important things. Remember, from the first image we are taking two things. First is your all the values from 0 to 7, and also the round value what it's getting. Okay, these two things you remember, that will be utilized later. Now step number 2. In step number 2, for the second image, what question you got, for that we'll be having this one. So you can see we have given we have not given this as RK, we have given this as ZK, for example. Okay, so ZK will also be having the same 0 to 7 values, and here also NK value will be same as I told you before. So you can see that these values are there. Then we have PDF values. So how we are calculating PDF value, you know, previously I have already explained you twice. And CDF value also you know how to calculate, that also you know. Now what is this value? This is multiplied by 7, that also you know, and this is the rounded value. Okay, this time we are not going for we are not going to add the pixel values like that, like the step number 1. Okay, here we are going to give the rounded value only. So from the first image, what we did, we got your NK value and we got the new value of your, we have got the new value, we have got the RK value, and we have got the rounded value. Okay, and here from this we are going to take the rounded value. So these three values only we need for the actual matching. Here comes the main part. So matching actually involves these three things only. Okay, so first one is your RK and rounded SK from the first image. Okay, and we are also getting the rounded value of zk. So we have three tables: table number 1, table number 2, and table number 3. Don't consider this table for now. Okay. So what is the next step? We have got three tables. Now for the first value 1, start looking where is 1 here in this table. Where is 1? So 1 is available here. So if 1 is available here, we have to match its RK value. So its RK value is 2. Okay, once again I'll tell you, this is very important. First we have to start to look for the first value. First value is 1. We have to look where is 1 here. So 1 we already found here. It means we have to just see that what if these two are actually available. So where is the corresponding value? Corresponding value is 2, and that 2 value will be fitting here. Simply we'll copy and paste it here. Now we'll look where is 3. So 3 is available here. So what is the corresponding value of 3? Corresponding value of 3 is 3. So that will be going to the next value of this 3. So that will be writing here. Now what is the next value of 4? Here is the catch. 4. 4 is not present anywhere in this case. So in that case, what we'll be doing? In that case, we'll be taking the nearby value. So what is the next value of 4? The next value of 4 is 5. But since 5 is not present, what we are going to do here? We are going to look for the 6. So which is the first 6? We can take this 6 or this 6. But we have to take the first 6. So what is coming here? So the corresponding value of 6 is 4. So we'll be taking 4. And 4 will be coming here. Now, what is the next value? 6. For 6, already the value is available, and that is your 6. So the corresponding value of 6 is 4. So we'll be taking again the 4 value here. Again, for the next 6 also, we'll be doing the same. Then we'll look for the 7. 7 already some value is present. Yes, 7 is actually present, and the corresponding value of 7 is 6. Okay, so for this 7 also the same thing will happen. For this 7 also the same thing will happen, and since all are pointing to the same value, and the answer will be your these 6s. Okay, we are not taking any other values. Okay, so that is the thing. So this is called your mapping. Now how we are going to do the final mapping pixel is actually available. One last step is available. So what is this one? This is your input image. The first value we calculated, no, that one. That we should keep here, and we have to take this mapping value. Since mapping value we have taken from here. Okay, so this mapping value will be keeping in this one, and we'll be keeping the input value. So what we have done, we have taken the screenshot of this one. Now next what we are going to do, you just see the gray levels. Okay, so gray levels, you can see here, as per this answer, as per this mapping value, are you seeing any representation of 0? 0 is present there? No. So because of that, the first gray level value will become 0. 1 is there, 1 is also not there. So 1 is not there, so we'll be taking this 1 also as 0. And then we'll look into 2. 2 is available? Yes, 2 is available. Okay, so 2 is available means the first value will be your 70 value. Okay, now 3 is available? Yes, 3 is available. So the second value will be taken. Okay, that is your 95. Then 4 is there, 4 is there, 4 is there, but 4 is actually available 3 times. Okay, so 4 is available 3 times. So because of that, what we'll do, the next values will be taken directly. Directly means all 3 values will be taken in a single time, like this. Because 4 is coming 3 times. 2 came, 0 and 1 is not available, so we'll be straight giving 0 and 1. 0 and 1 will be 0. Okay, 2 is available, but 2 is mapping to 70, so we'll be giving 70. 3 is mapping to 95, so we'll be giving 95. Now you can see that the last one, 4 is coming 3 times, so because of that we'll add all 3 and we'll be getting 95 here. The answer will be 95. Do we have 5 here? No, 5 is not present. So 5 is not present, so because of that we'll go for 0, and then we'll look for 6. 6 came how many times? 3 times. So remaining values will be taken for 6, and it will be 25 plus 15 plus 5. That is your 45, right? That is your 45 value. And 7 is there? No, in this complete thing 7 is not present. So because of this, you can see that histogram of input image was this one, and histogram of your target image was this one, and we are getting, because of these values, we are drawing the new histogram is this one. So for 0 you can see there is nothing, for 1 there is nothing, for 2 there is 70, for 3 we have 95 for 4 we have this complete value. This is over 85 plus 60 plus 35, and this value is 0, and sixth value is also this one 45, and this value is actually not present. So this is your final resultant histogram. Now what image will form from this one will automatically adjust this pixel so that will be looking better to our eyes. So this was histogram matching. Thank you.